Hey, what's going on, everybody? I'm going to go over LeetCode question 21, merge two sorted lists. You're given the heads of two sorted linked lists, list 1 and list 2, and you need to merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists. Return the head of the merged linked list. Okay, so we have two linked lists here, and they're already in sorted order, but we need to return an entirely new linked list also in sorted order, using all of the values from both lists. So as you can see here, we have the first linked list in red and the second in purple. If we start at the first head of the second linked list, we see that, it's 1. And then we decide which path to go from there. So we see, okay, should we add 3 or 1? Well, obviously we want to add 1, so we're going to add 1. And from there, we continue our path to 2. And then we decide from 2, do we want to go down to 3 or 4? So we go down to 3, add 4, and then finally 4 again. So each iteration we're taking, we want to make the decision whether to take the node from the first linked list or the node from the second linked list. So if we kind of draw this out here and say, so this is going to be L1 and L2. And because we're returning a new linked list, let's say there's some dummy node that's just going to be empty. Let's just call it D. So D is going to start at current, or current is going to start at this dummy node. And we see, okay, is the node at L1, so we're going to make this L1, L2. Is the value at L1 less than L2? We'll know they're equal, so we can take either path. So let's just take the L2 path, okay? And now we want to update our current from here now to here, because this is the first node in our new linked list, okay? And now we're going to decide, okay, is the next node at L2, so we can update L2 here, and L1 stays the same. Is the node at L2 less than the value at L1? Well, no, it's actually greater. So we want to say current.next is equal to L1, okay? So now this points to L1, and currently our node is going to be, so we're going to say new list currently looks like this. So now we have 1 and 1 so far. And now we want to make the other decision. So whenever we add this value, we're going to update the pointer at whatever linked list we're at. So this is now L1. And we see, okay, is L1 less than L2? Well, yes, it is. So we're going to set that equal to this. And now this is our current value. So now we're going to point that to 2. And we continue this logic. So we're going to update L1. And we're going to check, is this value less than whatever values at L2? Well, no, it's greater. So we're going to point down to L2. And L2 gets updated and current stays here, because this current value decides which path to go from here. Okay, so now we're pointing at 3. L1 is up here, L2 is here. And since they're both equal, we'll just say this is going to be our current value, okay? Okay. And now this is our current value. And if you remember, we've been updating the pointer for each list every time we add that value to our new list. So this is going to be in some empty space L2, which is actually null. And then we check, okay, well, L2 is null, so if L2 is null, then we want to check if L1 is null. Well, it's not. So it's fair game to add this value because it's in sorted order anyways. And that's finally going to be our new list. So 1, 1, 2, 3, 4, 4. Okay? And if we want to code this out, we want to create a dummy node or dummy linked list, and we'll just call it dummy equals new list node, and let's just give it some initial value. And we also want to set the current value equal to dummy. So we're going to say list node cur is pointing to that first node. Okay? And the loop is going to continue while L1 and L2 is not equal to null, because we need to look for valid values. So while L1 is not equal to null and L2 is not equal to null, then this is where we start deciding which node are we going to add to our new linked list. Okay? So first we'll check, okay, if L1.val is less than L2.val, then we want to add that to our value. So we're going to say cur.next is equal to L1 because it's the smaller value. And we're going to say L1 is equal to L1.next. Okay? And else, we're going to say cur.next is equal to L2 because that's the smaller value, and L2 gets updated to L2.next. And we can't forget to update the current value also, because if you remember, we initialize current to be the start value, and we need to update that because that's kind of, I guess you can say, the tail of our linked list. It needs to point to the next value we're adding. So we need to update that for every new node that we're adding to our new linked list. So cur gets updated to cur.next. Okay? And there's an interesting edge case that we need to be aware of. So if we just return cur.next, or actually it should be return dummy.next. You see that there's some cases that are failing here. So like we said, there could be one node that has a null value, right? Like if this happens to be the second to last value we add, and then L2 gets updated to null, then we just check if L1 is not equal to null. So if L1 is not equal to null, then we just say current.next is equal to this. So first we check if L1 is not equal to null, then cur.next is equal to L1. If L2 is not equal to null, then cur.next is equal to L2. And if we run this, it should fix that problem. Okay, and submit it. And that looks pretty good. So, yeah. Edge case, one value, or no, it is not null. Okay. Right. Because like we said, we added the second to last value, and there's no need to worry about this anymore. We're not going to add anything because null, we don't want to terminate the new linked list at null. But what we do want to check is we exited the loop because this condition failed. This condition failed when we reached this point and we said L2 is equal to L2.next. But we still have this node up here at L1. So this is where this if condition gets fired and we're able to add that final node to our linked list. So it's important to be aware of those edge cases when you're traversing two linked lists and one node is null and the other is not. You have to be aware of those cases, right? So this is a fundamental linked list problem that appears in some other questions like reorder list and things like that. So be aware of those edge cases and work through these problems with a whiteboard like this or just pen and paper. That really helped me with linked list problems. Thank you for watching and stay tuned for the next one. Thanks.